Good morning, guys, of grade 11. Today we're going to start a new lesson. We're still in chapter 22. We talk about the organic compounds, organic materials. So today we're going to talk about the functional group. So after we end of the introduction of what is the organic compounds, and we know that organic compounds, they are compounds that mainly contain carbon atoms. Then in section 2, we start to study about the hydrocarbons, the basic type of organic compounds, which are the saturated and the unsaturated hydrocarbons, alkanes, alkenes, and alkynes, and know how to name them and all of that. So now we're gonna pass to section 3, which is the functional groups. So what are functional groups? As we said in the first lesson, that there is a huge variety of organic compounds, or we have a lot of types of organic compounds. So what make each organic compound different than the other if they share this or have the same number of carbon atoms? So that's here the point, okay? So for example, if we have organic compounds that contain four carbons, okay, so could it we have kind of derivatives or just kind of different, okay, organic compounds that could be produced from these four carbons? Yes, that depends on what are the functional groups are attached to these four carbons. So what is a functional group? Functional group actually is just one atom or a group of atoms that is responsible for certain properties for the compound. That means once an organic compound contains this atom or this group of atoms, it will have a certain characteristics and that will make it able to do certain chemical reactions. So it has a certain behavior. Okay, so we classify different compounds that contain this functional group as a category or as a group together. Let's take an example here. So for example, if we just watch this table or looking at that table, okay, so we're gonna find that we have different organic compounds. All of them, they contain four carbons, as we said in the beginning of the session. What is the difference? So that the basic hydrocarbon, that alkane, okay, that have four carbons, so it's butane. So that's the basic hydrocarbon. If you just look at its physical properties, its melting point is minus 138.4 degree, while its boiling point is negative 0.5, and at density about 0.5. So the same here, if we just replace one hydrogen by a hydroxyl group OH, okay? So you could observe that its characteristics dramatically changed, okay? There is a huge change in the boiling point and the melting point and even in the density. So this little OH is considered as a functional group. Actually, it's the functional group of alcohols. So any organic compound that contain OH, we're gonna call it alcohol, okay? So that's now is called as butanol. So here also, let's look at this one. For example, here we just replace these three hydrogen on the fourth carbon here by COOH. So COOH is another functional group, which is the carboxyl group. It's the group of acids. So like this here, we could find also this little change because of the dramatic change in the physical properties and so on. So like this, we could find here that the functional group, it's one atom or a group of atoms that are responsible for specific properties or characteristics of an organic compound. And regarding to this, okay, each compound that contains this functional group will have a certain manner of chemical reaction or have a certain behavior during chemical reaction. So we classify them into categories. So let's find what are the different functional groups that could be included in an organic compound and what are the groups. So first of all, that's the functional group OH, the hydroxyl group. Okay, once it attached to a chain of hydrocarbon, that means alkyl group. We know the alkyl group, like for example, ethyl, methyl, propyl, butyl. That means a chain of carbon that lack for one hydrogen. So this instead of this hydrogen, it will be substituted by OH, for example. So any organic compound that contain hydroxyl group, it's okay. We're gonna call it alcohol, or it will be classified as alcohol. So alcohol is one class or one group of the organic compound. What is alcohol? It's just alkyl group with hydroxide, okay, group or OH group. Here we find the other one, which is alkyl halide. So what is the alkyl halide? Okay, so the alkyl halide actually it's just an alkyl group in which one hydrogen or the this hydrogen which is missed is going to be substituted by one of the halogens. What are halogens? Actually, halogens, they are elements which found in the group 17 in the periodic table that are fluorine, chlorine, bromine, and iodine. So once this X refers to one of these elements, fluorine, chlorine, bromine, or iodine, and or whatever. So let's get an example to clarify the idea. For example, here, if we get the methyl group, okay, so methyl group, so it's CH 3 and they still have a bond that's free. So CH3, what's its bond for chlorine? So that would be called methyl chloride. Okay, so that is alkyl halide. Okay, so ether, okay, it contains that's in the functional group, okay, in which we are gonna find there are two R's attached to one oxygen atom. So that is the functional group, oxygen atom bonded by two single bond with two alkyl groups, okay. So we call them ether, okay. Here another one, the COH, okay, this one, or CHO, actually it's pronounced like this, CHO. So that's the group of aldehyde. Okay, so the any organic compound that contains CHO, it's aldehyde, and CO, that's ketone. Okay, N, that's functional group, which we call it amine, and COH, that is the carboxyl group, or we call it the carboxyl acid. So it's an acid here, and the COO, that's ester. So should we memorize this functional group and the classes? Yes, of course. Okay, you must memorize them. So let's pass here to talk about each class in detail, okay, or we'll know more about each class. So you could observe the first category is alcohols. So alcohols are very common and known, especially nowadays. Every one of us, okay, now is moving due to the coronavirus. We are already moving, carrying alcohol bottles in our pockets, okay. So what is alcohol? Actually, alcohol is just an organic compound that contains the hydroxyl group, the OH. So it's just, that's why the general formula is ROH. Whatever the chain of the carbon is, and it's just connected with OH. So it could be methyl, prop, penta, hexa, whatever, okay? So hexyl, butyl, whatever, okay, ends with OH. This OH, or the presence of hydroxide group in the alcohols, make the alcohol have certain or specific properties that it could build a kind of hydrogen bond between different alcohol molecules. Let's get an example to clarify the idea here. For example, let's take any alkyl group. For example, let's take we say propyl. So propyl, that means there are three carbons. So here that's the three carbons. So here that is the propyl group. It's CH3, CH2, CH2, and we miss one hydrogen here. So instead of this hydrogen, it will be carrying OH. So in that case, okay, we call this propanol. Okay, so one propanol, because the OH is carbon number one, so that is one propanol. This OH, once we have another, okay, molecule, the same molecule like this one, okay, so C, we're just gonna make it right here like CH2, C, like this, okay. So what would happen, you could find that this, okay, this OH is a polar, okay, compound. That means the OH is the oxygen is partially negative while the hydrogen is partially positive. That will allow to form a kind of hydrogen bond, okay, the kind of attraction between the partially positive hydrogen and partially negative oxygen, like in water compounds, okay. So somehow all the molecules of alcohol, they are attached to each other, okay. So that's explain a lot of properties of alcohols. That's why it's considered to be cohesive, and also that's why it's also to be cooled, because it's this kind of hydrogen bond is able to absorb a lot of heat energy. So that's why when you put alcohol in your hand, that feel that's always is cooled. So that's why we use alcohols in a lot of cosmetics, okay, like creams, lipsticks, and body lotions, and so on. So the most common alcohol that is used in this cosmetic material is known commercially as glycerol, but actually its IUPAC name is 1,2,3 propanol. Okay, so propan because it's just three, okay, carbons. Tri because it has three hydroxide groups in carbon number one and two and three, and the all because it's alcohol already. So that's mean its formula is gonna be like this, okay? Three carbons, and the three carbons carry three OH groups, okay? One in carbon number one, and another one in carbon number two, and one in carbon number three, and then the rest will be hydrogen as usual, okay? So that is glycerol, or 1,2,3 propanetryl, okay? So that's here which is used in a lot of cosmetics purposes. Also, alcohols have a lot of uses, okay, rather than used in cosmetics, okay. Alcohol nowadays, they are considered as alternative fuel, okay. That means sometimes people, they add certain kinds of alcohol to their fuel or to the gasoline, just to make a better performance or efficiency for the motors of cars and different automobiles. Okay, so here also because that alcohol burn more efficiently rather than the gasoline nowadays. Okay, they make kind of mix between the gasoline and the alcohol to form a kind of fuel. We call this, okay, gasohol. Okay, which is paired to be used in different motors and engines and so on. So like here we got a hint about what are alcohols, okay, and what are the uses of alcohols. Let's pass to another kind of organic compounds, which are alkyl halides. What are the alkyl halides? Okay, so the alkyl halides, they are just alkyl group R that is combined with one of the halogens, as we said, which is fluorine, chlorine, bromine, and iodine. So that the general formula is Rx. Okay, so actually they are commonly spread. Okay, or they are have a lot of uses in our daily life, and we use a lot in lab. And actually, the most important or the most known Khalid Akai, which has a lot of announcement, and all the universe is caring about the CFC, or we call the fluorofluorocarbons. Okay, so what are CFCs? Okay, they are the chlorofluorocarbons, which means they are halide alkynes which contain the chlorine and fluorine halogens. Okay, on the same alkyl group. So actually, the most famous one, which is the ferrion. Okay, so the ferrion gas, which we use it in the refrigerators, aerosols, ACs, and so on. Okay, so we have two types of ferrions. Because one is known as trichlorofluoromethane, and the other one is dichloro-difluoromethane. That means here we just have three carbon chlorine and one fluorine attached to carbon atom, while here we have two chlorine and two fluorine. So why this kind, or why CFC are very important, and different, all the universe is interested about them, because actually we find that there are this kind of halide alkyls, or the CFCs, which are we use in our daily life. They have a very bad impact on the ozone layer. They are the main reason of the ozone depletion, okay, or which is known as the ozone hole. So what happens here, actually, once we use these gases in our daily life and they start to be emitted out from our ACs, refrigerators, for any reasons, even during using the aerosols, and they start to pass to the atmosphere. Once they expose to the solar radiation or the solar energy, they start to dissociate or break down and release some free chlorine atoms. We call them the chlorine radicals. Okay, these chlorine radicals, or these free chlorine atoms, they are able to combine with the ozone gas in the ozone layer and break down the ozone gas into oxygen and ClO, or the chlorate group. Okay, but unfortunately this ClO later will, okay, bond with another oxygen and separate into oxygen gas, and the chlorine will return free, which make it able to combine with another molecule of ozone gas. So one free chlorine atom is able to destroy a lot of ozone molecules. Okay, and it will never finish. Okay, it will keep repeating. So that is a disaster. Imagine if we have about billion atoms, so, or million atoms, so how much it's going to break down from the ozone layer. So once scientists figure out this, a lot of protocols and a lot of kind of agreements between different nations, okay, to reduce the usage of CFC and prevent using them, okay, and different things. That's why nowadays when you just get an aerosol can, okay, for example, perfume can or something like this, okay, and you can read on it, so you see free of CFC or just CFC, and there is a slash on, which means that it doesn't use CFC. Another one of the most famous halide alkyl is C2F2, which is tetrafluoroethene. So this tetrafluoroethene, okay, that is very important compound, which is known commercially as the Teflon. What is special about this Teflon? Actually, the bond between the chlorine and fluorine is inactive or inreactive bond. Okay, so that make this one is very stable at higher temperature, even to 300 to 5 degrees Celsius, and also it's make its surface is very smooth. Okay, so it reduces the kind of friction with other objects. That's why we could use this part in the internal parts of engines or something, part, or the internal parts of machines, which cannot be lubricated, to reduce friction, and it's and same time it's able to stand with high temperature. And also because its surface is very small, Teflon is used in making non-stick surfaces, okay, like what we're using in the frying pans, okay, when we know as the Tefal pans, okay. So actually we call Tefal because it contains Teflon. So here like this, okay, then that's the second category or second class of organic compounds. Now we'll pass to the third one, which is the ethers or are ethers. So what are ethers? Actually, ethers, they are a compound that contain functional group, which is a single oxygen atom bonded with two sides by two different alkyl group. So here like this, it's ROOR. Okay. So actually, because also the bond between O and R somehow is unreactive, so they are somehow stable compounds. They don't react that much. So that's why always they are used as solvents. So here there are examples, a lot of ethers in our daily life. So we can find that ethers, okay, and some sausages like the vanillian sausage which we have, okay, or this, sorry, the vanillian sauce we have, okay. So you could find that here this is the functional group, and here also that the functional group, okay, which we found in lavender, okay. So and so on, okay. A lot of ethers they are found in our daily life. So that's the part we're gonna stop at, guys. Please study very well from your textbook, and if you have any question or something is not clear, I'm waiting to hear your question. Thank you and goodbye.